Hi everyone, just a little bit more about our differential equations when it comes to separating them to solve them. I want to give you guys some examples of ones that you couldn't separate, and that's what you guys are going to be just quizzed on slightly today, just on your matching. For instance, if I wrote dy over dx is equal to xy, we could separate this because we want all the x's and y's to be kind of on the same side. All the x's on the same side and all the y's on their own side. So we can separate this by saying, hey, how do I move the y over? How do I move this dx over here? So we would have to divide the y to get to the dy side. That's why it's on the bottom. And the dx, we would multiply dx to both sides, right? And that would become x dx. That's not a problem. That's an easy way. What about if we had exponents? So a big popular one that you see oftentimes is dy over, let's say dx is equal to, I'm making this up, let's say it's going to be 3 to the x minus y. Well, if you notice that the x and y are in the exponent, xy in the exponent, how am I supposed to separate that? Well, just like we talked about in our lesson previously, we can separate that because that's actually 3x divided by 3 to the y. And now they're separated. We can go ahead and we had to first do this transition, and then we have dy over dx is equal to 3 to the x over 3 to the y. Then now we can move our x and y's over to each other's side. We're going to move the x's over this way, and the y's over this way. When we do that, we end up with 3 to the y power dy is equal to 3 to the x dx. And then we can integrate afterwards, whatever that may be. Now, when can't I separate it? Well, there's a couple of problems. The whole goal oftentimes is through multiplication and division. We're shifting stuff over through multiplication and division. Now let's try something that kind of doesn't really work out. If I write dy over dx is equal to x plus y. I still want the x's to be on, I want the x's to be on the same side, and I want the y's to be on the same side. Now, if we try it, let's go ahead and try moving stuff around. If I just, let's say I want to move the y to this side. Dy over dx minus y is equal to x. We say, hey, that looks like it's coming together. And then you want to multiply the dx. You're going to move it over here. But when you multiply, you have to multiply everything. Let me write this. Multiply everything by dx. And that leaves dy minus y dx. And now we're stuck. Dy minus y dx. And now we're stuck. How am I supposed to get this dy over here? If I tried, dy is equal to y dx plus x dx. Well, I could try dividing out the dx, but then we end up with a y plus x, and we end up in this really unhelpful way. We're kind of lost now. So it turns out this is not separable, okay? Not separable. Well, let's try something else that might look like it's separable. Let me see if it is. Dy over dx is equal to x squared, not x squared, xy plus 3y. is this separable? Because there's a plus sign. Our last problem, let's take a look again. Our last problem here had a plus sign or a minus sign, and that didn't work out. Well, dy over dx is equal to, let's see if we can factor out what's in common, y, x plus 3. Hey, now if you look at it, see how this is all self-contained? And this guy here is by itself? We could separate these now. Let's move the y's to the same side. Dy over y is equal to, let's move the x over, x plus 3 dx. And that is separable. So just be aware, some of these problems are not always going to be separable, but the ones that they give you should be. And we want to know when we can separate and when we can't, and also be able to use our tools to be able to move stuff around. Let's do one more. Just as a, what if I write dy over dx is equal to e to the 3y minus 2x. Now, as we said before, we have our x and y's, the next moment, and we're kind of stuck there. So we're going to say dy over dx. We're going to rewrite this as if I'm subtracting exponents, I'm actually dividing powers. So e to the 3y divided by e to the 2x. And now we can separate it. And it'll be dy over e to the 3y is equal to dx over e to the 2x. Now to rewrite this, if I really wanted to, I prefer the e not being in the denominator. So we can write it as e to the negative 3y dy is equal to e negative 2x dx. And now if we really wanted to, we can then take the integral of both sides. Okay, hopefully you found this tutorial helpful. Leave a comment if you have any questions.